Welcome to microcontroller episode 73. The objective to make digital clock using IC CD4026 using ATMEGA328 microcontroller in a standalone way. The Arduino Uno and 4026 IC based clock. The Uno-controlled 4026 based clock and calendar circuit diagram is presented in this page. This section deals with the standalone circuit diagram and its wiring. The components needed for this project is presented in this page. The standalone digital clock with date and time with ATMEGA328 chip full circuit diagram is presented here with RTC DS3231. The pin diagram of microcontroller ATMEGA328P DIP package is presented here. CD4026 IC description. The CD4026 IC is a 16-pin CMOS digital integrated circuit that combines 5-stage Johnson decade counter with 7-segment decoder. It counts incoming clock pulse from 0 to 9 and directly drives a common cathode 7-segment LED display without needing a microcontroller. The main feature, dual function, acts as both decade counter and a 7-segment driver. Voltage range 3 volt to 18 volt DC. Display compatibility, designed specifically for common cathode display. Cascading output includes a carry out pin to link the multiple IC together for multiple digit counting. Low power, uses very little power, typical of CMOS 4000 series. The pin configuration and function description is given in this page. One can also refer to the data sheet of the IC manufacturer for details. Wiring of CD4026. Using individual CD4026 IC means you need a dedicated chip for every single 7-segment display digit. A full 6-digit clock, hours, minutes, second, you need 6 CD4026 IC and 6 7-segment display common cathode. To make the code work correctly with the individual chip, you must cascade them in pair using the clock inhibit and carry out pin 5 pins. Chip-to-chip cascading architecture. The code groups the display into 3 independent pulsing channels: seconds day, minutes month, hours year. The 6 chips are wired as 3 independent 2-digit counter block. Within each 2-digit block, wire them like this so that the 10th digit automatically counts when the 1st digit rolls over from 9 to 0. Full 6-digit hardware wiring guide. To prevent ghost numbers or frozen display, every individual chip must have its own control pin tied to the correct voltage level. Power and display type. Display requirement. You must use common cathode 7-segment display. The CD4026 output a high signal to turn the segment on. Resistors. Connect 220 or 330 ohm resistor between each display segment and the IC. Connect the common cathode to the ground. to protect a LED. The standard pin connection for all 6 is given in the table. Pin 3 connected to 5 volt, pin 2 connected to ground, pin 15 connected to Arduino pin 7. All the pin 7s of 6 ICs are connected together and connected to Arduino IC pin 7. Pin 16 VDD 5 volt power supply. Pin 8 VSS ground power supply. Pin 6, 7, 9, 10, 12 and 13 display segments from A to G respectively. Arduino control pin connection. Second day pair rightmost 2 digit. Connect Arduino pin 8 to pin 1 of the seconds 1 chip. Minutes month pair middle 2 digit. Connect Arduino pin 9 to pin 1 of the minutes 1 chip. Hour year pair leftmost 2 digit. Connect Arduino pin 10 to pin 1 of the hours 1 chip. 3. Critical hardware troubleshooting tips. Floating pins. Do not leave pin 2 clock inhibit or pin 15 reset disconnected on any chip. Floating pin pick up static electricity from the air, causing digits to skip numbers randomly or freeze. Decoupling capacitor. Place 0.1 microfarad ceramic capacitor physically close to VDD pin 16 and VSS pin 8 of each CD4026 chip. High-speed counting pulses create power spike that can glitch neighboring chip. The blanking pin, pin number 14. Leave pin 14 unused, common blanking disconnected. The following section shows the code used for running the digital clock. The 14-page C++ code for Arduino IDE is given here. One can copy and paste and compile, or can request for the code file from the author. Step-by-step instruction to use Universal Programmer to flash. The Universal Programmers tested for this work is T48 and Topol 8. Please don't forget to configure the fuse setting before flashing. The opening window of T48. Chip selection is shown in this page. Click and load the hex file, which is compiled and saved by Arduino IDE. Navigate and select .ino.hex file. Please follow the setting to load the file into the T48. Please verify the setting before flashing. Position the chip in the zip socket. Flash to load the .ino.hex file into the chip. Some microcontrollers are locked after programming. If you are using the previously used chip to rewrite this program, please follow the steps given to troubleshoot. Method 1. 16 MHz crystal in the zip socket. Method 2. ICSP mode of flashing. The UNO is used as an intermediary to flash the program into the standalone chip. The pin wiring diagram is given in the table in this page. T48 test conclusion. T48 failed to recognize the chip of ATMEGA and failed to write the code into it. Method 2. Top-all 8 flasher. On opening the top-all, this page appears. Select the MCU and its type. In this case, microprocessor unit ATMEGA328 PD package is selected. Go to Configuration tab and follow the settings given in this page. Note the IC chip position given in the Position tab and place your microcontroller accordingly in the zip socket. Select File Load menu to load the ino.hex file. Click on Go button to flash the code to the chip. The chip mounted on top-all is captured in this image. Top-all testing conclusion. The top 2013 works flawlessly. This is a recommended tool for flashing for ATMEGA328. Note: remove the chip from the zip socket, and now the microcontroller is ready to work standalone. Wiring of the circuit. The standalone digital clock with date and time with ATMEGA328 chip. Full circuit diagram is presented here with RTC DS3231. The tactile switch wiring is given in the part 1. ATMEGA328 to tactile switch wiring is given in part 2. ATMEGA328 to 4026 display unit wiring is given in this part 3. ATMEGA328 to RTC wiring is given in this part 4. The power supply to the entire clock. The clock will work on 5 volt 1 ampere power supply, and it can be provided by C-type mobile charger. One can use the C-type female in the breadboard and power the circuit. The complete test bed assembled in the breadboard is shown here. Working of this code is described in this section. Menu navigation using the momentary press switch. Run mode is 0, set mode is 1, set mode again pressed will give to mode 2, set mode again pressed will give set day, and the next press of set will set month, next press the year. This cycle repeats, and the set or run final press will load the value entered into the RTC memory. Setting menu continuation. Button routing. Pressing button up or button down adds or subtracts the value depending entirely on the active mode state. Modulo maths keeps the value from exceeding the real world time constraints. Flashing and isolation visual. While adjusting setting, the code stops updating all the screen. Instead, it resets the layout and pulses only the specific register pin you are altering. If you are modifying minutes, only the middle display module will actively clear and pulse up to your set target. Data commitment. Pressing button run at any time or pressing button set when navigating past the year mode, execute save all to RTC. This packs your custom edit to the BCD format and upload them over I2C bus into the DS3231 non-volatile memory bank. 4. Simple audio alarm track. During active running mode, if a alarm embedded is flipped true, the algorithm monitors the current timeline. If the current hour matches with the alarm hours, minutes matches with the alarm minutes, it flags an active alarm event for the first 15 seconds of that minute. This activate the buzzer follows a clean rhythmic pulse. The buzzer rings during even seconds, silent on the odd seconds. A working image of the clock is captured. Here the clock is running. It will run for 0 to 40 seconds. The working of the clock is shown in this image. The photo of the calendar running is captured. From 40 to 60 seconds, the calendar will be displayed. The working of the calendar is shown in this image. Complete PCB design is available. If anyone is interested in making PCB or commercializing it, may please contact the author. Conclusion. This is an attempt to use decade counter with MCU to show data and date and time. This is cost effective. Most features like temperature, humidity, display can be added. The C++ code is an excellent learning platform for the student. Conclusion. This is an attempt to use the decade counter with MCU to show date and time. This is cost effective. More features like temperature, humidity, display can be added. The C++ code is an excellent learning platform for the students. This will work as a standalone clock, calendar and alarm. One can contact the author for tips, support, assistance and guidance. Please contact for code and support. Kits are available for learning. Projects for schools and colleges can be designed. Contact the YouTube owner. Subscribe to my YouTube channel. Please subscribe to my YouTube channel by following the link. Thanks for watching. See you in the next episode.